going to do is special things, right? Special things, that means special forms of integration, right? The special form in integration. So put the heading special forms. This is very important. Most of the time they ask related questions, right? The first form what we are going to do is e to the power x f of x plus f prime x dx. So what is the answer? This is e to the power x f of x plus c. Okay. Right now, this is a form. That means if you have e to the power x and something, any function here, and the differentiation of the function also there, then you can straight away write like that. So you have to prove that. Okay. So that is very important. Just copy this. Right. Just copy this. If e to the power x into f of x plus f prime x. Okay. So this is, there is a proof, right? There's a proof. So this is how to prove. So first of all, say this is I. So I will be, I multiply this e to the power x f of x dx plus e to the power x f prime x dx. Okay. E to the power x f of x dx plus e to the power x f prime x dx. So now I'm going to keep this. I'm not going to do anything to this one, right? But I'm going to do this one. So I'm going to integrate this. So how to integrate this? Okay. How to integrate this? So you have, this is bypass, using bypass. So so using bypass, e to the power x is easy to integrate. So I keep this as a u, this as a dv by dx. So e to the power x as a dv by dx, f of x as a u. Okay, so then what you can do, so you keep the f of x and integrate the e to the power x, that is e to the power x minus integrated thing into e to the power x and differentiation of other f prime x dx. Here you have same e to the power x f prime x dx. So what happens? This minus e to the power x f prime x and plus e to the power f prime x, they both are cancelled, and the answer will be e to the power x f of x plus c. C is an arbitrary constant. And arbitrary constant. So it's easy to prove. Okay, only 3 steps, and it takes only 40 seconds to do that. Okay, so please copy this. Sometimes they may ask these kind of questions by giving this. That means you have e to the power x and here the multiplication of e to the power x. So inside the bracket, something there. So in f of x, and you have the f prime x together. So immediately you can put e to the power x f. Okay. So please copy this. I'll give 1 minute. So example given. So if e to the power x sin x plus cos x dx, if e to the power x sin x plus cos x dx, that equals, you can easily, you can here sin x, here differentiation of that. So e to the power x sin x. Let's see. This is the answer. So now I'll give exercise. So 1, please do it. E to the power x, e to the power x, e to the power x into 1 plus x squared plus tan inverse x dx. Second one. So if it's like this, then easy. Sometimes you have to make like that. So in that case, that's a bit hard. So please try to do this one. So sometimes e to the power x e to the power 1 plus x all things squared dx. So sometimes they may ask something like this. Not always like this. It's easy, you can see and you can do it. Right? So 2 questions, I'll give some time. Okay. So I erase this part. This is okay. No. That's the theory part. So because I'm going to erase, I sent the questions there to the group, right? So I can erase it and look at that, and I can put it. So the answer for this one is very easy. Only thing is, if you differentiate this, this won't come. This is the other way around. So you have to differentiate this and to obtain this. So you have to write like this. You have to write this one, you have to interchange, right? So tan x must be here, and 1 over 1 plus x squared must be there. But since this is positive, so easily I can put e to the power x tan inverse x plus c. Is it clear? Is it clear? Right. So we will. So we have come to the final part of the integration, but the second question. What about the second question? Second question is a bit crucial, right? Because x into e to the power x over 1 plus x, a whole thing squared. Here you won't see anything in direct form. That means e to the power x and the f of x plus f prime x, you won't see that in the, okay? Straight away you won't see. So you have to make it. So this is bit hard, but you have to practice. Here, in that case, what happens? E to the power x, it goes like this. So I can say this is x over 1 plus x whole thing square. Is it clear? So what I can do, so you know, you can write this as a partial fraction. This is a partial fraction. So that is the one I expected. So if you can write this as a partial fraction, so you can write by putting a over 1 plus x plus b over 1 plus x squared. You can do that, but other than that, there is an easy method. You add 1 and subtract 1. Okay. You add 1 and subtract 1. So why? Then easily you can write this over this 1 over 1 plus x. X plus 1 over 1 plus x whole thing squared. X plus 1 over 1 plus x whole thing squared. That is 1 over 1 plus x. And minus 1 over 1 plus x whole thing squared dx. So now you can see if this is f of x, what is the differentiation of this? 1 over 1 plus x, if you differentiate, this is 1 over u form. 1 over, we learned that 1 over u form, if you differentiate 1 over u form, minus 1 over u squared into du by dx. So this is 1 over u form. So if you differentiate this, minus 1 over 1 plus. So you can put this minus as plus and here. So if it's f of x, straight away this is f prime x. If you differentiate this, minus 1 over 1 plus x squared into, so if you differentiate x, that is 1. So straight away answer is e to the power x into over 1 plus x plus c. So very important and easy question. If you know the technique, this will be easier. Otherwise, it's not. Okay. Right. Please copy this. Please copy this. Okay, so do this question. Question number 3. Carefully you have to do. Question number 3, carefully you have to do. E to the power x x into 2 plus sine 2x over 1 plus cos 2x. So quickly do this one. Will you able to do this? Please rearrange and please do it. I'll give some time. Okay, hopefully you are trying to do this one. Hopefully. So what you can do, you have to simplify this. You keep the e to the power x. What you can do, so 2 sine. So here sine 2x, we can write 2 sine x cos x over 1 plus cos 2x, you can write 2 cos square x dx. So it's easy. So this 2, and this 2 will be cancelled. So you are having e to the power x 1 plus sin x cos x over cos square x dx. So individual divide. You divide this by this. So e to the power x. If you divide 1 over cos square x, that is sec square x. If you divide this by this, then 1 cos x will be cancelled. So sin x over cos x, that will be cancelled. So finally, this is tan x, this is x square x. So if it's f of x, this is f prime x, because if you differentiate tan x, you will get x square x. So if e to the power x is there, answer will be e to the power x into tan x plus c. So what is the answer? E to the power x into f of x. That is the answer. If it's f of x, this is f prime x. Right? Is it clear? So these are the special cases under the e to the power x into f of x plus f prime x form. Right? So I will explain again what happened. Only thing is we know that we have to keep the e to the power x away and we have to simplify this. So we have to make it in the form f of x plus f prime x. So it's there because 2 here sine 2x I expanded the 2 sine x cos x. 1 plus cos 2x is 2 cos square x. So this 2 and this 2 and this 2 will be cancelled. 1 plus sine x cos x over cos square x. I individually divide 1 over cos square x and sin x cos x over cos square x. So I didn't write that step here. But if you want, you can write that 1 over cos square x plus sin x cos x over cos square x. So later this becomes x square x. This is sin x over cos x, that is tan x. So you can write tan x plus x square x also anyway. So this is the answer. Is it clear? Right. So I erase this part. Okay, hopefully we have done, right? Okay, so do this one. Fourth one, ping and do. Okay, integration of e to the power x square root of 1 plus x squared. Square root of 1 plus x squared. X squared plus x plus 1 dx. Please do that one. I'll give some time. Okay, so enough time given. So we'll do this. So this is very important thing. So our responsibility is, okay, so e to the power x, and somehow we have to make f of x plus f prime x. Okay, so that is a special form what we are learning now today. So how to make it? So this is bit hard. You have to think and do. So how to make it? Um, so there are many methods. That what you can do is here you can do like this. Square root is there, no? So take this and this. So I can write that 1 plus x squared plus x. I can write like this. And I can write individually divide. Okay. I take x squared plus 1 and plus x. I'm going to divide separately. So what will happen? This one I can write square root of 1 plus x squared. This one I can write square root of 1 plus x squared plus this one will be x over square root of 1 plus x squared. So now can you see that one? If you differentiate this, what do you get? If you differentiate this, what do you get? 1 over 2 into root of 1 plus x squared into 2x. If you differentiate this, 1 over 2 into square root of 1 plus x squared into 2x. 2 gone. X over square root of 1 plus, you are getting this one. That's it, finished there. So if you do, so you can straight away put the answer. E to the power x into square root of 1 plus x squared. Is it clear? So please try to understand. Okay, so that's fine. So again, I'll explain this, what happened. So somehow we have to make f of x plus f prime x form. This is a special form. We are learning under the special form. So if so, you can write e to the power x into f of x as an answer. So what I did, I took x squared plus 1 and plus x individually divided. So it will be like this. So this is a differentiation of this. Okay. So put the second special form that is very, very important. Okay. So I introduced that one also today. So second special form. So that is very important. 0 to a f of x dx. You can write as a 0 to a f of a minus x dx. Okay. So actually, if it's 0 to a f of x dx, so here the limits, only the problem involving with limits. And you can write the same 0 to a, but what you can do, instead of a, you can put this minus this, a minus x. So actually this is the special version of the another one. So I'll tell you, this is the real version. A to b, say a to b, f of x dx. So they're asking this one also. A to b f of x. So actually this is integration of same a to b you have to add these two, a plus b, and subtract the x. So instead of x, you have to put that. But instead of x, you have to put by adding these two and subtracting the x. So this is um, the real one. The special one is this. Okay, because here we are having 0. So if you put a equals 0 and b equal a, so you will be getting this. So we will come to this one later. So we will do this one now. Right? Okay, so 0 to a f of x dx, 0 to a f of a minus x dx. You have to prove. That is very, very important. The proof is expected in the exam. So is it true? So for an example, before we go to the proof, I'll do one example. If 0 to pi by 2 sin x dx, that is equals to the same 0 to pi by 2 sine, no problem with the sine. Instead of x, you put pi by 2 minus x. Actually, pi by 2 plus 0 minus x. So that is pi by 2 minus x. That is later you can put cos x. So that's correct. So you may wonder about that. So if you integrate sin x and if you integrate cos x, both are same. No, not both are same. But if you put the limits like this 0 to pi by 2, then same. So that's why it says. Okay. So before I prove this, I want to clear one point. And because many students, more 98% of students, they struggle in this case. So 98% of students, they struggle in this case. So the first, before I go to the proof, I will explain that one. Guys, will you think x squared dx equals t squared dt? Is it correct? If it's x squared dx equals t squared dt, is it correct? Or say x into dx, say x into dx, will it be equal t to dt? Will it be equal? So answer is no. So no, because this is in terms of x. So we are going to have x squared by 2 plus c. This is in terms of t squared by 2 plus c. Is it clear? So these two are not equal because two different expressions. So if that's so x and x must be equal to t and the constant also, right? Okay. Is it clear? But if you put the limits, say 0 to 2, say 0 to 2, then will it be equal? So answer is yes. Why? If you put 0 to 2, the answer will not be in the x. Answer will be a number. That is we call finite value. So finite value, if you put 0 to 2, so answer the limited one. So finite values. Okay. Okay. So in that case, if you do that, x squared by 2, 0 to 2. So t squared by 2, 0 to 2. So if you put that, that is 4 squared, 2 is the answer. Here also 2 is the answer. Both are correct. So then, so you need to know the concept. If you just integrate x into dx, that won't be equal. Well, that will not be equal to just integrating t dt. But if the limit is there, the same limit, then both are equal. Okay. So you know the concept. So now I clear. Because I found in my experience, many students, they won't accept the proof of this because they at the end they have confusion. So to remove the confusion, now I'm saying at the beginning, okay, so like this t dx, x dx and everything. So it's a different between. Okay, so now we come to this. So I have to prove this equal this. I'll take this. So easy for me. So consider f of a minus x dx. So consider. So you have to consider this, right? Then always you need to know there is a minus x. Why I took this? Because it's easy to substitute. Because instead of a minus x, I can put t. So f of a minus x equals t. Let's. So immediately minus dx dt because we learned the substitution fully, right? So integration we are going to finish now. So now what we have to do, you have to change the limits. You have to change the limit. If x equals 0, t will be a. If x equals a, t will be 0. Okay. So say this is I. So same I can be written now. Instead of say I'm changing to t, so 0 become a and a becomes 0. And f of a minus x, that is t, minus dx is minus dt. Sorry, dt. So dx is minus dt. So here after I don't have space to write. So I am writing here I equals. So you know this, there is a minus and a to 0 ft dt. So there is an interesting thing. The minus will change the limits. So this will go up and this will come down. Why? Because normally you put this and subtract this, no? F of a minus f of b. If the minus is there in front of that, so it is going to be f of b minus f of a. So that's right. So if you want to omit the minus, you have to change the limit. If you want to omit that. So I'm writing without minus, so I have to change the limit. A to Z. Okay, both are same. Because if you substitute after integration, if you substitute, the minus will come. So other than that, you change the limit and you integrate. That's easy. So this is going to be ft dt. This is going to be ft dt. So finally, I can write without hesitation 0 to a f of x dx. I can write without any problem because now you understand. Because ft dt, some students they are, so ft dt means t equal x, no, but you took t minus something like that, no. So they may ask like, no, not like that. They understood, okay, this is not equals to ft or anything. So this is going to be in numbers, the finite value, because since the limits are given, right? 0 to a, 0 to a. So ft dt, you can put fx dx, or fy dy, or fu du, or anything. So please copy this down. Very, very important proof. Right. The similar way you will prove that a plus b minus x equals t. Similar way you prove that. Okay, so quick. As soon as possible, please do it. Right. So very important thing. This is you have to take a minus x as a t and minus dx dt, changing the limits. A0 ft minus dt. So what happens, minus there, minus will change the limits. So without minus, you change the limits and write. That's it. So example, I'm going to erase this one. Example given. So you can start with I equals, say, 0 to pi by 2 sine squared x dx. So I can start with sine squared. So what is the point of doing like this? That is the next question, no? So that's why I gave one example. So if you want to integrate sine squared x, if you have the limit 0 to pi by 2, and if they ask you to do using this, then you can. Otherwise, you can't do straight away. So in the question, they must give. So now this can be written as sine squared, no problem. Instead of x, you have to put pi by 2 minus x. pi by 2 minus x into dx. That's it. Instead of x, you have to put pi by 2 minus x. This minus this. Okay, so that there is known one. That is cos squared x dx. So now we have to integrate cos squared x to find the sin squared x. No, but easy way is if you do that, 99% of these type of questions will be done by adding these two. Adding these two. So before you substitute and after you substitute, two things you have to add together. 99% of questions will be solved using that. So if you add that 2y, so 2y will be 0 to pi by 2. Here sin squared x plus cos squared x 1 dx. So answer is x 0 to pi by 2. So you have to put pi by 2 minus 0. And so finally I will be pi by 4. So answer is pi by 2. Integration of this or integration of this also same. So example is given. So since example given, I'll give exercise. So exercise. Okay. It's better. So this exercise will be say 0 to pi by 2. That's easy. Sin x over sin x plus cos x. Okay. Please do this. Sin x over sin x plus cos x. Please do it. Okay. Oh, sorry. My mic is off. I didn't check. From exercise 1, my mic is off. Okay. So that means the starting of this, isn't it? This is just a question. No, this is okay. No problem. So this is from the starting. Okay. From the starting, mic is off. Okay. So no problem. So it's just, you don't need to worry about that one now. Okay. Okay. So I'll explain again. No problem. I didn't erase this. No. This is an exercise 1. No. Right. So 0 to pi by 2 sin x plus cos x dx. So you put pi by 2 minus x. So instead of x, you have to put a minus x. So you have to pi by 2 minus x. Actually, this plus this minus x, but this is 0. So that's why this minus x. So pi by 2 minus x. So this is sine pi by 2 minus x over sine pi by 2 minus x plus cos pi by 2. So this is cos x, this is sine x, this is cos x. So if you add these two, denominators are same. So sin x plus cos x on the top and bottom cos x plus sin x, that will be 1. So I straight away I put 1 dx, that's I can put over, just leave it. So if you integrate that is x, then pi by 2, that's it. So you divide by 2, that's it. So now you can do this one. Here. So say this is I, that is very important. So 0 to pi minus x instead of x, sin squared pi minus x dx. So I equals, 0 to pi. Okay. So this is pi minus x, but sin pi minus x is sin x. So it's again sin squared x. There is no change there. It's again sin squared x. Here x sin squared x. Here pi minus x sin squared x. If you add these two, 2i will be 0 to pi. If you add, what happens? Take the sin square as a common. X minus x gone. So it's going to be pi sin squared x only. Do you understand? If you add this, take the sin square as a common. Here x, here pi minus x. X plus minus x will be gone. Then only pi. So you can take the pi out. And this is 2i. Integration 0 to pi. Sin squared x, if you want to integrate, you have to put in the cos 2x. 1 minus cos 2x by 2. I put the by 2 here. So the continuation is here. Okay. So I will continue here. So 2i will be pi by 2. So if you integrate 1, that is going to be x minus, if you integrate cos 2x, that is going to be sin 2x over 2 and 0 to pi. So limit is there, that is 0 to pi. So again, 2i equals pi by 2. Now we have to substitute the pi there. So it's pi. If you substitute a pi in sine 2x, that is sine 2 pi, that is 0. Minus, if you substitute 0, 0, all are 0. So 2 pi will be pi squared by 2. So I will be pi squared by 4. So very interesting question. Very interesting question. Pi squared by 4. So this is a way of doing these kind of questions. So now you are capable to do 2009 past paper, B part, I think. 2009, question 6, B part, I think. So you are capable to do that one. And 2014, you are able to do. And 2010, 16, and there are many 2017, all these are past paper questions. So under this topic, very important. So we will be doing that. So the homework now 2009, 2014, right? 2009, 2014. And if possible, go to the 2006, the 13 or 10, 2010, and 2017. So that's also there. 2017, very interesting one. 2017. And latest 2018, 19. I think so. 19 also there. Okay. Is it clear, all of you? Okay, so I'm going to conclude the class right now today because we have enough homeworks, right? So what are the homeworks? Already you have various homework under the substitution, 2005 past paper, 2006 past paper, 2010 past paper, substitution is given, right? In 2010 past paper. First you had to do 2005, then you had to do 2006, if possible do 2011, 2015, all under the substitution, right? 2016 if you want, and you can do 2018, right? Now you are okay to do anything. So we'll be doing like that. Okay, if you have gone through the questions, there we can discuss. Now the extra thing came 2009. It will, I think you will finish the question 2009 within 2 minutes, right? Like this. And 2014, that's also very important question. And 2017 and even 2010, right? And 19, 2009. So enough past paper homeworks are there. So so that's the end of that integration. I think, yeah, so all the special and some other specials are there. The different kind of questions, something different kind of question means something like this. If sine x over sine x minus alpha, so you have to integrate this. So what you have to do, you have to inside, you have to put minus alpha plus alpha. Then you can expand and do individual dividing. Those things are there. Just, so extra things are there. So, and this limit changing in a different way, those are there. So this will be discussed in the paper class, right? So integration officially finished with the theory. So past paper questions, some past paper questions are remaining. So normally this is I think 13 class today for integration. So we spend 13 classes, but more we have to spend more. So another 4-5 classes we can spend for the past paper doing and discussing. But it's better you have to do first, then only I will go through. Okay, guys, it's a good time to do this. So we are going to conclude the integration and we are going to start the complex number instead of integrations in coming days. In between, you have to do the past paper. If possible, do the past paper and keep it, and you can, you can send it. It's better to keep it in the hard copy. So whenever it's possible, you can hand over to the tutor if possible. Okay, so do these questions. These are the past paper questions, right? I will do the discussion. We will find a time and we'll do the discussion. In between, we can start complex numbers. Already we finished the matrices, so we had to start the complex numbers. And plate, it's going. We have to start. We have finished that central gravity. See, it's just we started and we are going to finish that. Only part is we have to do that proving one and some techniques, right? So hope you have done in that way. 2020 past paper also. Hope that 2020, 2019, 2D we have to do. So that after that you can do anything. So we are going through the past papers again in center of gravity. As soon as possible, we are going to start the SHM there. So there we are going to start the SHM. Here we are going to start the complex number. In between, there is one thing that is wedges. We have to finish it with the past paper questions and other. So after that, so wedges, I think we will be able to finish within 2-3 classes. So in that case, we are going to start the statistic. Okay. Is it clear? Right. So all together, if we start the statistic and probability, so we'll be able to finish the syllabus end of this month, right? Okay, so circle is there. So that you can cover the circle while going through the complex numbers because yes, I know. Right. Okay, bye. See you guys. So don't miss the class. Okay, if you miss the class, that's a huge loss for you. So I'm just keep going on like this. Okay, so it's the problem is sometimes class we not happening. Actually, we are managing different time, but try to cope up with this because you can do that. Okay, so it's very important. So since you know that this is very important,